Imagine you're driving for 50 miles on an open interstate.
Right.
You never see a single patrol car sitting in the median.
Not one.
Yeah, you never spot a radar dish, and you definitely never see a camera flash.
Just clear roads.
Exactly. You cruise the entire corridor feeling, completely unmonitored. And then, 2 weeks later, you open your mailbox to find 3 separate speeding citations.
Ouch. Yeah, that's rough.
Complete with high-resolution, time-stamped photographs of your vehicle.
It sounds like science fiction, honestly.
It really does. That scenario sounds like something out of a near-future dystopian novel, but according to the stack of research we are unpacking today, well, it is the mathematical reality of the modern highway.
It is. It's happening right now.
So, welcome to the deep dive. Today, we are looking at a massive silent shift happening on our roads.
A really profound shift, yeah.
We are moving from the era of the momentary snapshot to the era of continuous invisible tracking.
Which is a complete reversal of how we've always done things. Because the traditional way we manage highway speed is essentially geographical luck.
Right. It's a game of hide and seek.
Exactly. You crest a hill, you see the reflective decals on a police cruiser, and, your foot instinctively hits the brake.
We've all done it.
We all have. You are measured in that single millisecond, at that specific mile marker.
Yeah, just that one snapshot in time.
Right, and if you pass the radar gun at the legal limit, you're clear. It doesn't matter what you were doing 3 miles prior.
You could have been doing 90.
Exactly. We built an entire driving culture around this highly localized point-in-time enforcement.
And that's what's changing.
Completely. The transition to average speed enforcement fundamentally rewrites that dynamic. We are abandoning the snapshot and, we are tracking the timeline.
The timeline, that shift from a localized trap to a timeline is exactly what we're going to pull apart today.
It's a big one.
Because if the old system was a game of reflexes, a cat and mouse dynamic between you and the highway patrol, the new system is an equation.
Pure math.
Right. It's an algorithm quietly running in the background of our infrastructure. So let's get straight into the mechanics of this corridor clock. The underlying premise is basic physics, right? Distance divided by time.
That's the core of it.
But applying that across miles of public infrastructure requires some heavy technical lifting. I mean, we aren't just talking about a stopwatch and a Polaroid camera here.
Oh, far from it. It's not just a guy with a stopwatch. The architecture of a segmented corridor is, it's a massive distributed computing environment.
Okay, lay it out for us. How does it physically work?
So you establish an entry point and an exit point, separated by a known fixed distance.
Right, like a finish line and a start line.
Exactly. Let's say the distance is exactly 10.4 miles.
Okay, 10.4 miles.
When your vehicle crosses the entry threshold, an infrared camera captures an image of your license plate.
Just the plate.
Mostly the plate, yeah. And that capture is time-stamped down to the millisecond.
Wow.
Yeah. So you drive the 10.4 miles, you cross the exit threshold, and a second camera captures your plate again with a new timestamp.
Okay, let's unpack this for a second.
Sure.
Capturing a license plate at 80 miles an hour at night in a rainstorm, that introduces a huge margin for error.
You would think so, yes.
Right, because optical character recognition isn't flawless even on a flatbed scanner in a quiet office.
No, it's definitely not.
So I have to imagine the system requires intense back-end filtering to avoid mailing a ticket to the wrong person just because, I don't know, a raindrop made an F look like an E.
The environmental variables are exactly why these systems don't use regular cameras. They rely on specialized ANPR, which stands for automatic number plate recognition.
ANPR, got it.
These aren't standard optical cameras. They use infrared illumination matched with incredibly fast shutter speeds.
How fast are we talking?
We're talking capturing 60 frames per second at 1/1000th of a second.
That's incredibly fast.
It has to be. The infrared bursts illuminate the retroreflective paint on your license plate while completely ignoring the ambient lighting.
Oh, so it doesn't care if it's midnight or noon?
Exactly. It ignores the headlights of the car behind you, the glare from the sun, the rain.
It just sees the plate.
Right. The software isolates the rectangular bounding box of the plate, corrects for the physical skew or angle of the car moving between lanes.
Because you're not always perfectly centered.
Exactly. Then it applies a high-contrast digital filter and extracts the machine-readable text.
So it's stripping away all the visual noise and boiling the vehicle down to a pure data string.
Just ones and zeros.
But let's push this out of the sterile environment for a minute. What happens when the physical line of sight is broken?
What do you mean?
Well, say I enter the corridor in the left lane, and then I get boxed in by a massive 18-wheeler just as I pass the exit camera.
Ah, right.
The ANPR can't read my plate if a truck is blocking it. It seems like the timeline breaks if one variable goes missing.
And a simple point A to point B system would absolutely break under those conditions.
Right.
That is why the modern deployments, detailed in the research, use what we call segmented corridors.
Segmented corridors.
Yeah, the infrastructure doesn't just consist of 2 nodes. It might be 10 nodes strung along a 20-mile stretch.
Oh, so it's not just start and finish. There are checkpoints.
Exactly. It creates overlapping zones of verification.
Okay, so if the truck blocks me,
If a semi-truck blocks your plate at node C, the algorithmic sequence doesn't fail.
it just skips it.
The system simply bridges the data from node B to node D. It builds a composite timeline of your journey.
It stitches the data points together.
Exactly.
Which also implies that the system's internal clocks have to be flawless.
Oh, they do.
Because, if the internal clock on the camera at node B drifts by 2 seconds, it artificially alters your travel time.
And 2 seconds is a massive deal at highway speeds.
Right. 2 seconds of latency could mathematically push a legal driver into a speeding violation.
Which is why network synchronization is the Achilles heel of any distributed timing system.
So how do they fix that?
To prevent clock drift, these camera nodes are continuously synchronized with NTP network time protocol servers.
Okay.
And those servers are linked to atomic clocks, often via GPS time signals.
So they're literally checking the time against an atomic clock constantly.
Constantly. The data packets are stamped at the edge, on the camera itself, rather than waiting to be stamped when they reach a centralized server.
Because sending it to the server takes time.
Exactly, which would introduce network latency.
Right.
Furthermore, before a violation is ever finalized, the back-end system runs a parity check against the state's motor vehicle database.
A parity check, like double-checking its work.
Basically, it verifies that the plate number extracted by the OCR matches the physical vehicle type registered to that plate.
Oh, I see.
So if the algorithm reads a plate and pulls up a motorcycle registration, but the camera clearly captured a 4-door sedan.
The system knows it messed up.
Right. It identifies the mismatch and discards the event completely.
Wow. So the system demands absolute data integrity before it moves forward.
It has to, legally.
This fundamentally alters what the infrastructure is actually doing.
What's fascinating here is that the system no longer asks, were you speeding right here?
Right.
Instead, it asks, did you travel this entire stretch of geography faster than physically allowed?
It is pattern verification over sustained distance. You cannot game a mathematical absolute.
You really can't.
Which brings up the obvious question. If this technology is so airtight and the math is undeniable, why isn't this ubiquitous on every highway in the country?
That's the billion-dollar question.
Right. If we look globally, average speed enforcement isn't some experimental theory.
No, it's been around for a while.
European nations and parts of Canada have used these systems for years.
Decades in some cases.
Yeah, the sources mention that drivers in the UK are completely accustomed to their SPECS cameras.
Yeah, the SPEC system is everywhere there.
And the Tudor system in Italy has been active for over a decade. But in the United States, there has been a massive historical resistance to this.
A huge resistance, yeah. The U.S. has a very different driving culture.
It does.
The resistance here stems from a deeply ingrained cultural relationship with the automobile.
The idea of the open road, freedom, all that.
Exactly. Combined with strict constitutional thresholds regarding automated enforcement.
Privacy concerns, mostly.
Privacy, due process, a lot of legal friction. However, the source material indicates that as of 2026, those legislative barriers are eroding.
It's finally happening here.
It is. We are seeing a distinct, multi-phase rollout across the country.
So let's look at the mechanisms of that rollout, because it isn't happening on the wide-open stretches of the interstate first, is it?
No, they aren't starting there.
The primary beachhead for this technology in the U.S. is the construction work zone.
The work zone is the perfect testing ground.
States like Pennsylvania and Maryland have active operational corridors right now specifically tied to work zones.
They do.
And New York is launching pilot programs under the same banner. Why is the work zone the skeleton key for getting these cameras approved?
It comes down to political capital and legal thresholds.
Makes sense.
Attempting to pass a bill in a state legislature authorizing blanket, continuous surveillance on an open highway?
That would cause an uproar.
Immediate pushback from privacy advocates and drivers' rights groups. It's a political non-starter.
Right.
But framing the deployment strictly around the protection of vulnerable road workers That fundamentally changes the debate.
Because you were talking about environments where construction crews are operating heavy machinery mere inches away from vehicles traveling at highway speeds.
Exactly. And it's politically impossible to vote against a measure designed to stop cars from hitting road workers.
You look terrible voting against worker safety.
Precisely. The legislative maneuvering is brilliant in its simplicity. State legislatures authorize the technology, but they ring-fence it.
They limit its scope.
Right. They lower the legal threshold required to implement automated enforcement, but only within the temporary boundaries of a designated work zone.
Okay.
Once the cameras are up, the transportation departments meticulously study the data.
They treat it like an experiment.
They do. They track the compliance patterns, the reduction in speed variance, and the operational reliability of the ANPR systems.
They use the work zone as a laboratory.
A highly controlled laboratory.
And once the system is proven to be accurate and the public becomes vaguely accustomed to its presence, the ring fence expands.
That's the next phase we're seeing now.
Right, because the research points to states like Virginia and Georgia moving beyond the construction narrative.
They are.
They are laying the groundwork to target high-risk highway segments, stretches of road, historically plagued by extreme crash frequencies.
The transition from temporary work zone to permanent installation is where the infrastructure becomes truly integrated.
And the most striking aspect of these permanent installations is how thoroughly they blend into the background noise of the commute.
You hardly even notice them.
They are incredibly passive. When you think of a traditional speed trap, it relies on a visual threat.
Right, the flashing lights.
You see the high contrast markings of the patrol car. Even traditional point speed cameras, like the ones used for red light enforcement, rely on a brilliant, blinding flash to let you know you've been caught.
It's very performative.
Exactly, it's a performance. But these average speed corridors are practically invisible.
There is no performative element because the system does not need to alter your behavior in that specific microsecond.
By law, there is usually signage indicating that the speed is monitored by a camera.
Right, they have to tell you it's there.
But the signs don't point out the specific nodes.
No, they just say speed monitored by aircraft or camera enforced zone.
Right, you just pass underneath standard overhead gantries. The cameras look indistinguishable from electronic toll readers or automated traffic counters.
Just gray boxes on a pole.
And the infrared flash is completely invisible to the human eye.
You'd never see it.
You can drive through a 5-mile tracking corridor at midnight, have your plate scanned 6 times, and never perceive a single indicator of surveillance.
It operates much like a background update on a smartphone or a laptop.
Oh, that's a great way to put it.
The new operating system installs quietly, the code rewrites itself, and by the time you realize the interface has changed, the new parameters are already in effect.
The cameras are just there now. But the human operating system hasn't updated yet.
Not at all.
We have a driving population that has spent decades being conditioned by the snapshot.
Conditioned to hit the brakes.
So let's explore the behavioral collision course here. What happens when a driver who is hardwired to react to a visual threat suddenly finds themselves inside a silent mathematical corridor?
It forces a complete rewiring of driver psychology.
Because the old tricks don't work.
Right. The traditional enforcement model taught drivers to think in localized points, which creates a highly specific neurological reflex.
See cop, hit brake.
You see the threat, you step on the brake. The threat passes, you apply the accelerator.
Which creates its own problems.
Huge problems. This is the root cause of what traffic engineers refer to as the phantom traffic jam or the accordion effect.
The accordion effect is fascinating because it illustrates just how fragile traffic flow really is.
It's incredibly delicate.
You're driving in the fast lane, traffic is flowing smoothly, and suddenly the brake lights ahead of you flare up.
And you panic brake.
Right. Everyone comes to a grinding halt. You sit there for 2 minutes, creeping forward, assuming there's a massive accident ahead.
Waiting for the wreckage.
And then, abruptly, the road opens up. There's no accident, there's no debris, there's seemingly no reason for the stop.
That phenomenon is what we call a kinematic wave.
A kinematic wave.
Yes. It is driven entirely by the delayed reaction time of human beings.
Break that down for us.
Okay, so driver A spots a patrol car parked on the shoulder and drops their speed rapidly from 75 to 60.
Right?
Human reaction time introduces a 1 to 2 second delay before driver B registers those brake lights and responds.
Because nobody's paying perfect attention.
Exactly. Because of that delay, driver B has to brake slightly harder to avoid a collision, dropping their speed to maybe 55.
Ah, I see.
Then driver C reacts even later, braking down to 45.
It's a chain reaction.
The shock wave travels backward through the flow of traffic, amplifying in severity with every vehicle.
So it gets worse the further back you go.
Much worse. By the time that wave travels a mile backward, vehicles are forced to come to a complete dead stop just to absorb the compounding delay.
A single tap of the brakes creates a mile-long parking lot.
It happens every single day.
But average speed enforcement neutralizes that initial trigger.
Completely.
Because tapping your brakes at the camera does absolutely nothing if your overall pace across the 5-mile corridor remains too fast.
Right. The driver quickly realizes that the brief moment of compliance under the lens is mathematically irrelevant.
It doesn't save them.
Not at all. If your entry and exit timestamps calculate to an average of 82 miles per hour, dropping your speed to 65 for the 3 seconds you were beneath the gantry has zero impact on the citation.
The system measures the entirety of the behavior.
Not just the micro moment.
I want to challenge the architecture of this, though, because anytime you deploy an automated system, human beings will immediately look for the edge case loophole.
We always do.
We established the equation is distance divided by time.
Right.
Theoretically, couldn't a driver tear through the first 3 miles of a 5-mile corridor at 100 miles an hour, pull onto the shoulder, check their email for 10 minutes, and then pass the exit camera?
That's the classic hypothetical.
Right. Their total time crossing the distance would result in a perfectly legal average speed. The algorithm would see a compliant driver, even though they were driving at lethally reckless speeds for half the trip.
Well, from a purely mathematical perspective, the equation allows for that exact loophole.
So it is possible.
If the total duration satisfies the legal average, the algorithm will not flag the vehicle. However,
There's always a however.
if we connect this to the bigger picture, the source material focuses heavily on the sociological realities of the commute. Human behavior entirely negates that mathematical loophole.
Because pulling over for 10 minutes completely defeats the psychological purpose of speeding.
Exactly. Speeding is almost entirely driven by the desire to reduce travel time.
You want to get there faster.
Right. The cognitive dissonance required to drive at extreme, highly stressful speeds, only to intentionally park on the shoulder of a highway to wait out a clock.
It makes no sense.
It is insurmountable for the average driver. The behavioral data proves it simply doesn't happen.
So people don't game the system like that.
No. Instead, drivers abandon the mental load of trying to game the system at all. They transition from reactive avoidance, constantly scanning the horizon and modulating their speed.
Stressful driving.
Very. They transition from that to continuous compliance.
It's easier to just set the cruise control to 65 and take your foot off the pedals entirely.
It creates a cognitive off-ramp.
Yeah.
There is no single moment to beat anymore.
Right.
The entire environment becomes the measurement, which means the most efficient physical and mental path forward is just maintaining the baseline.
And when hundreds of cars collectively adopt that continuous compliance, the phantom traffic jams vanish.
The flow normalizes.
The kinematic waves flatten out because the sudden, violent braking events cease. The corridor clock acts as a mathematical shock absorber for the highway.
That's a great analogy.
But this entire behavioral shift relies on the threat of consequence. If you fail to maintain that continuous compliance, the algorithm flags you.
And then the system kicks into gear.
And the legal architecture of what happens next is a radical departure from everything we know about traffic law.
It's a completely different paradigm.
Here's where it gets really interesting. You are not getting pulled over, and you are not getting a standard speeding ticket. Let's dig into the legalities here.
Sure. The process bears almost no resemblance to a traditional traffic stop.
No flashing lights in the rearview mirror.
Exactly. When the algorithm identifies a violation, the data package, the high-resolution images, the timestamps, the OCR read, and the mathematical output is bundled and sent to a processing center.
All the evidence in one digital folder.
Right. Often, a human reviewer performs a final visual check to confirm the license plate matches the registration data.
Just to be absolutely sure.
And then the citation is mailed to the registered owner of the vehicle.
It's a registered owner. That is the critical pivot point.
It changes everything legally.
A traditional patrol officer pulls over a car, walks up to the window, and identifies the person sitting behind the steering wheel. The citation is written to the driver.
Right.
This camera system identifies the metal plate bolted to the bumper.
Which strips away the most common defense in traffic court. I wasn't the one driving.
It wasn't me defense.
Exactly. To make this automated system function within the U.S. legal framework, municipalities had to reclassify the nature of the violation.
How?
A traditional speeding ticket is a moving violation. It is a criminal or quasi-criminal offense that attaches to your driver's license.
It generates points, it impacts your insurance premiums.
Right. It's tied to you, the operator. But these corridor citations are generally classified as civil violations.
Civil violation.
Yes. They are administrative penalties. They are structured, legally speaking, much closer to a parking ticket than a moving violation.
Why is that distinction so crucial for the courts?
It alters the burden of proof and the concept of strict liability.
Okay, walk us through that.
In a criminal moving violation, the state must prove beyond a reasonable doubt that you specifically committed the infraction.
They need to prove I was holding the steering wheel.
Right. In a civil administrative framework, the state relies on the presumption of liability attached to property ownership.
Meaning?
If your vehicle is parked illegally in front of a fire hydrant, the city doesn't need to prove who parked it there.
They just ticket the car.
Exactly. The owner of the property is liable for how the property is used. By classifying average speed violations as civil matters, municipalities bypass the constitutional friction of identifying the driver.
So if I loan my car to a friend and they treat the highway corridor like a time trial, the algorithm mails me a $150 civil penalty.
You get the bill.
I don't get points on my license, my insurance company doesn't find out, but I am financially liable for the behavior of my property.
This administrative approach is basically the only way these systems survive judicial scrutiny in the U.S.
Because courts accept that logic.
Courts have repeatedly ruled that as long as the penalties remain strictly financial, meaning no points, no license suspension, no threat of jail time, the strict liability placed on the registered owner is constitutionally permissible.
But it still triggers massive friction regarding due process and the Sixth Amendment.
Oh, absolutely.
The Confrontation Clause guarantees a defendant the right to confront their accuser. In traffic court, you can cross-examine the officer.
You can ask them questions.
Right. You can question their vantage point, ask when their radar gun was last calibrated, or challenge their memory of the event.
Are you sure it was my car?
Exactly. With a corridor clock, your accuser is a proprietary black box algorithm.
And the legal framework doesn't eliminate your right to contest the citation, but it drastically changes the battlefield.
You are no longer arguing against a human narrative.
No, you are arguing against a data set.
How do you cross-examine a data set?
It's difficult. You have to attack the integrity of the data chain or the presumption of liability.
Give me an example.
You can submit documented evidence that the vehicle was stolen, providing a police report filed prior to the timestamp of the violation.
Okay, so proving it physically wasn't in my control.
Right. You can provide evidence that the vehicle was legally transferred or sold to another party. Or, you can't do those, you have to challenge the technical accuracy of the machine itself.
Which requires an incredibly high burden of technical knowledge.
A very high burden.
You'd have to subpoena the calibration logs of the cameras, demand the NTP server synchronization records to prove latency in the timestamps.
You'd essentially need to be a network engineer.
Right. Or point out a clear, undeniable optical character recognition failure in the photographic evidence provided.
It requires finding a provable flaw in the equation. You have to outlogic the machine.
Good luck with that.
Yeah, the courts generally uphold the citations unless the defendant can demonstrate a specific, documented failure in the administrative process or the hardware.
So we have an undeniable mathematical framework, a passive silent infrastructure, a massive psychological shift toward continuous compliance, and a legal architecture built on civil liability.
That's the modern system in a nutshell.
The entire system is designed to fundamentally control human movement over long distances. Which brings us to the ultimate justification for building this massive data collection apparatus.
Why behind all of this?
Right. The transportation departments and the municipalities pushing this technology point to one specific metric: safety. Does putting every driver in a mathematical vice grip actually save lives, or is it just the ultimate automated revenue generator for local governments?
It's a fair question.
Yeah.
And the financial realities of automated enforcement are undeniable. They do generate significant revenue.
They make a lot of money.
They really do. However, the engineering data and the safety metrics from international deployments and early U.S. pilot programs are stark.
What does the data say?
The true justification for this system is absolute risk reduction.
Let's look at the actual physics of that risk reduction.
Yeah.
Because the primary data point the research highlights isn't just a drop in overall speed.
No, overall speed dropping is a secondary benefit.
Right. The real metric is a massive reduction in high-speed variance.
Speed variance is arguably the most critical metric in traffic engineering.
Variance. Explain what that means on the highway.
Variance measures the spread, or the standard deviation, between the fastest vehicles and the slowest vehicles on the exact same stretch of road.
Okay, so the difference between the grandmother in the right lane and the sports car in the left lane.
Exactly. A highway where everyone is moving at exactly 75 miles an hour feels smooth.
It's predictable.
It is. A highway where half the cars are doing 55 and the other half are weaving through them at 85. That feels incredibly dangerous.
It's terrifying, honestly.
The data proves that high variance is exponentially more dangerous than high absolute speed.
Wow, really?
Yes. When you have extreme outliers, the driver doing 95 in a 65 zone, the frequency of lane changes skyrockets.
Because they're dodging everyone else.
Right. And the closure rates between vehicles become unpredictable.
The closure rate, meaning how fast you're coming up on the car ahead.
Exactly. A driver checking their mirror to change lanes expects the approaching car to be moving at roughly the flow of traffic.
You glance, you see a car way back there, you assume you have time.
But when that approaching car is moving 30 miles an hour faster, the human brain misjudges the closure rate.
We just aren't wired to calculate that quickly.
We aren't, and that misjudgment leads to severe collisions.
So average speed enforcement effectively lops off the top end of that speed spectrum.
It does.
It eliminates the extreme speeders entirely, compressing the flow of traffic into a much tighter band.
It compresses the variance. Instead of a speed spread of 55 to 95, the corridor forces the vast majority of vehicles into a narrow band between, say, 65 and 72 miles per hour.
Everyone moves together.
When the variance collapses, the traffic flow homogenizes. Following distances naturally stabilize because no one is rapidly closing in on the bumper ahead of them.
The turbulence just disappears.
Exactly. The whole system calms down.
Which leads directly to the next critical data point. Crash severity.
This is crucial.
This is where the physics of the road become grim but unavoidable. The metric of success for these corridor clocks isn't necessarily getting the total number of fender benders down to zero. The goal is to ensure that the accidents that do happen are less violent.
This raises an important question about how we define safety. The physics of a collision are dictated by the equation for kinetic energy.
Back to physics class. Energy equals 1/2 the mass times the velocity squared.
Exactly. And the crucial part of that equation is that velocity is squared.
Meaning the danger doesn't scale linearly with speed.
No, it scales exponentially.
So an accident at 80 isn't just slightly worse than an accident at 70.
It's drastically worse. Dropping your speed from 85 miles an hour to 70 miles an hour doesn't just represent an 18% decrease in speed.
Right.
It represents an enormous exponential drop in the destructive kinetic energy your vehicle carries.
The energy that crumples the metal.
And impacts the human body. By eliminating the extreme high-speed outliers, the system guarantees that when an accident does occur...
Because they still will occur.
Right, whether it's caused by a blown tire, a medical emergency, or driver distraction, the energy transferred into the vehicles and the human bodies inside them is drastically reduced.
The crashes become survivable.
The data shows a direct correlation to lower fatality rates and less severe injuries.
Which is incredible.
Furthermore, it improves emergency response outcomes. When speeds are uniform and slightly lower, extrication from crushed vehicles is less complex.
Because the cars aren't as mangled.
Exactly. And circling back to the work zones, a uniform traffic flow of 55 miles per hour is a predictable environment for a construction crew.
They know what to expect from the traffic.
A chaotic, high-variance flow fluctuating between 45 and 80 miles per hour is a lethal lottery.
The system doesn't demand rigid, absolute perfection, though. If the speed limit is 65, the algorithm might be calibrated to only flag vehicles averaging over 71.
Right, to account for passing maneuvers and minor fluctuations.
But by placing a hard ceiling on the timeline, it compresses the kinetic energy of the entire highway. The physics of prevention are undeniable.
The math doesn't lie.
So what does this all mean for the daily commute going forward?
It means a lot of adjustment.
It means the era of momentary behavior detection is ending. The geographical luck of spotting the radar gun before it spots you is becoming obsolete.
It's going extinct.
We are entering an era of sustained compliance where every mile you travel is measured, aggregated, and verified.
It represents a profound shift in the relationship between the driver, the vehicle, and the state.
A huge shift.
We've discussed the undeniable math of distance over time, the silent back-end networks running parity checks, the structural shift to civil liability, and the exponential physics of crash survival.
Right, all the mechanics.
But aggregating all of this leaves us with a deep philosophical question about the nature of driving itself.
The culture of the drive is fundamentally changing.
For generations, the American highway has been synonymous with the concept of the open road.
It's a huge part of the American identity.
There has always been an inherent assumption of autonomy, a certain degree of freedom associated with getting behind a wheel and covering distance.
Just driving out into the horizon.
If our infrastructure is steadily transitioning into a continuous, unblinking data set where every movement is mathematically audited for absolute compliance, what happens to that autonomy?
That's the million-dollar question.
Does the freedom of the open road eventually turn into a giant, automated terms of service agreement?
Wow.
One where the physical infrastructure itself, rather than human officers, ensures that you never, ever step out of line.
That is a fascinating and, honestly, somewhat chilling concept to leave on.
It's something we're all going to have to reckon with.
The invisible boundaries of the modern highway acting as a continuous terms of service agreement. We want to thank you for joining us on this deep dive.
Thanks for listening.
The next time you merge onto the interstate, take a look at the gray boxes mounted on the gantries above you. Think about the invisible infrared flashes. Think about the timeline of your journey and ask yourself, are you already driving inside the corridor clock?